The Pythagorean theorem is a famous idea from geometry dealing with the side lengths of right triangles, which is a triangle with a right angle in it. If you call the two shorter sides of that triangle A and B, what are referred to as the legs, and you call the hypotenuse, which is the longest side, C, then you could set up the equation that says A squared plus B squared equals C squared. The length of one short side squared plus the length of the other short side squared equals the length of the longest side squared. So keeping that in mind, suppose you're given a triangle like this, where we're told the left side is x, the top side is x minus 7, and then that right side there, the longest side, is x plus 1. So what we're going to do is we're going to use the Pythagorean theorem to solve that. We're going to have one expression squared plus another expression squared equals another expression squared. The important thing with the Pythagorean theorem is that the longest side, what we call the hypotenuse of the right triangle, always goes in place of C for this formula. It doesn't matter which short side is A and which short side is B, but the longest side always goes in place of C. In this case, that's the x plus 1. If you have trouble visually figuring out which one's longer, the hypotenuse is always the side that is opposite the right angle. So in this case, x plus 1 is the one that's by itself. It's the one in the C part of the formula. The other ones, it doesn't matter that much. I'll just put x in the first one, x minus 7 in the next one. Okay. So this is how we would set up our formula for trying to solve this problem. Now here it helps to remember what it means to square something. Squaring something means we're multiplying it by itself. So for x squared, we have x times x. For x minus 7 squared, we have x minus 7 times x minus 7. For x plus 1 squared, we have x plus 1 times x plus 1, like that. And now we'll do some multiplying. X times x is x squared. For the next one, we use the FOIL method. First terms, x times x is x squared. Outside terms, x times negative 7 is minus 7x. Inside terms, negative 7 times x is minus 7x. The last terms, negative 7 times negative 7 is plus 49. On the right side, we use the FOIL method again. X times x is x squared. Outside terms, x times 1 is 1x. The inside terms, 1 times x is 1x. And then the last terms, 1 times 1 is 1. After all this multiplying, we need to combine like terms. On the left side, x squared plus x squared is 2x squared. Negative 7x minus 7x is minus 14x. And then we still have plus 49. On the right side, we combine our two like terms in the middle, and we have x squared plus 2x plus 1. Now, in order to solve this by factoring or using the quadratic formula, we need to have 0 on one side. So we need to move all the terms to one side or the other one. I find that the factoring is going to be easier if you move things to the side that has the bigger coefficient of x squared. So looking at these here, we have 2x squared on the left side, 1x squared on the right side. Let's move everything over to the left side. In other words, we want to get rid of everything on the right side. So we're going to subtract 1x squared from both sides. To get rid of the plus 2x, we subtract 2x from both sides. To get rid of the plus 1, we subtract 1 from both sides. Doing all that leaves us with x squared minus 16x plus 48 is equal to 0, like that. All right, so now we need to solve this by factoring. And let's see here. We would have an x at the beginning of each group. To multiply to be a positive 48, but add up to a negative 16, it may take a minute to work it out, but you would end up needing a negative 4 and a negative 12. So then we set both of those equal to 0. Here we end up getting x equals 4 and x equals 12. So at first it looks like this is going to be one of those where we've got two possible answers. Now notice the sides of our triangle are x and then x minus 7 and x plus 1. And we've got two numbers to think about right now that could be x. We got x equals 4 and we got x equals 12. If x equals 4, then x minus 7 is negative 3, x plus 1 is 5. That's not going to work. When you're finding side lengths, it wouldn't make any sense to say that a side length is negative 3. Negative side lengths don't make sense. So I'm just going to cross out that. That is not a possible triangle there. But if x is 12, then x minus 7 is 5, x plus 1 is 13. That works. They're all positive. So these would be the side lengths of our triangle in this case.